Okay, folks, get ready to dive deep. Today on Talk Tensors, we're taking a look at R3GAN, a simple baseline for image generation.
Oh, this is a fun one. It's like they took a time machine back to the early days of GANs.
Right, like, hold on, we're not done with you yet.
Exactly.
GANs, a few years ago.
Yeah.
Everyone thought diffusion models are going to take over, right?
Yeah, they were all the rage.
GANs were too unstable.
Too many weird artifacts.
Yeah, exactly.
But these authors, Yuan Huang, Aaron Gokaslan, Volodymyr Kuleshov, and James Tomkin, they're from Brown and Cornell.
Oh, wow.
And they're saying, hold up, a simple GAN can actually be stable.
Really?
And it can outperform those fancy diffusion models.
Well, now I'm intrigued. So break it down for us.
Yeah.
What is R3GAN and why should our listeners care?
So R3GAN, it's a new baseline model for image generation. Think of it as like a stripped-down, modernized version of Style GAN 2.
Ah, Style GAN 2. That's the one behind those crazy realistic deepfakes, right?
Exactly, yeah.
I remember seeing those videos, just unbelievable.
Yeah, Style GAN 2 was powerful, but man, it was complex.
Yeah.
And tricky to train.
Oh, for sure.
And what they've done here is they said, let's make it even better.
Okay.
Simpler, more stable.
I mean, that's a pretty big deal.
Huge.
Especially considering how much hype there's been around diffusion models.
Absolutely.
So let's back up for a second, okay?
Yeah.
Let's talk about the challenges with those traditional GANs.
Right. So the big ones, stability and diversity.
Okay.
You know, those were the big things that pushed people away from GANs.
Yeah.
And it's because GANs, they're based on this adversarial game.
Right. Generator versus discriminator.
Exactly. Generator's trying to make the fake stuff, the discriminator's trying to spot it.
Right.
But that game, that minimax optimization, it can be a real headache.
Really hard to get right.
Oh, it can go haywire so fast.
Like trying to balance, I don't know, a spinning plate on a stick.
Yeah, exactly. One little wobble and the whole thing.
It all falls apart.
It all falls apart. You get those weird artifacts, those nonsensical images. That's classic early GANs.
So what about diversity? What was causing that?
So that's where mode collapse comes in.
Sure.
You can think of it like, imagine a GAN trying to learn, how to create pictures of dogs.
Right.
Ideally, it should be able to make all kinds of dogs, different breeds, different colors.
Right, all the good boys.
Yeah, exactly. But what happens is, a lot of times, the GAN gets stuck, and it only makes one type of dog, like a golden retriever.
Ah, so it misses out on that whole richness of the data.
Yeah, it misses out on a lot of the potential there.
Okay, so it's like the GAN is stuck in a rut, only able to churn out the same thing over and over.
Exactly. It's got that one trick, and that's it.
Okay.
And that's what R3GAN is trying to fix.
Interesting. All right, so how do they manage to tame these GANs, make them more well-behaved?
Well, they've got this two-pronged approach. First, they made a totally new loss function.
The rule book for training.
Exactly, the rule book.
Okay.
And it's based on something called a relativistic pairing GAN loss,
Okay.
combined with zero-centered gradient penalties.
Now, those are some technical terms. Break it down for us.
All right, so the relativistic pairing part, that's all about making the GAN more diverse.
Okay.
Instead of looking at real and fake data separately, it compares them directly.
Oh, interesting.
So it forces the generator to come up with a wider range of outputs.
Okay, so it's like a competition pushing the generator to be more creative.
Exactly.
What about those gradient penalties? What are those doing?
Think of those as safeguards
Okay.
during training.
Right.
They make sure the discriminator, remember the one that's trying to spot the fakes?
Yeah.
Doesn't get too aggressive.
Okay.
It makes sure the discriminator doesn't push the generator too far away from a good solution.
Ah, so it's all about that balance, right?
Yeah, I got to keep them in check.
Generator and discriminator.
Yeah.
Working together, not one overwhelming the other.
Exactly.
That's pretty clever.
And here's the kicker. They actually have mathematical proof
Oh, wow.
that this combination of techniques, it leads to local convergence.
So the training process is guaranteed to converge to a good solution.
At least within a certain region, yeah.
Now, I'm no mathematician,
Right.
but I get that that kind of certainty is a big deal in AI.
Huge deal. A lot of existing GAN losses, they don't have that theoretical foundation.
Yeah.
It means we can be more confident that R3GAN will produce good results consistently.
Right. Unlike some of those older, more unpredictable GANs.
Exactly. It's like having a blueprint for a house rather than just winging it.
That's a good analogy. Okay, so they've got this stable and reliable loss function. What about the actual architecture of R3GAN? You said it was based on Style GAN 2, but simplified, right?
Yeah. They took style Jan 2, remember how complex it was?
Oh, yeah, it was a beast.
And they stripped it down to the bare bones, got rid of anything that wasn't absolutely essential.
Okay.
No more bells and whistles.
So, like decluttering a messy room.
Exactly. But they didn't just stop there. They took some inspiration from modern deep learning designs like ComNext and ResNet.
Ah, those are known for their efficiency.
Yeah.
And they're very effective in tasks like image recognition, right?
Right.
So it's like taking that decluttered room and then outfitting it with sleek modern furniture.
You got it. More efficient, streamlined.
I like it. So the big question, how well does it actually perform?
Right. Does it live up to the hype?
Do all these changes actually lead to better results?
Well, they put it through its paces, tested it on a whole bunch of image data sets. Stacked MNIST, FFHQ, CIFAR 10, even ImageNet.
Wow, the gold standard.
Yeah.
Okay, so spill the beans. Did it deliver?
Let's start with stacked MNIST. This one is designed to test mode coverage.
Right, the GAN's ability to generate a wide range of outputs.
Exactly.
Mhm.
R3GAN, full mode coverage.
Wow.
It captured every single variation in the data.
Okay, aced the diversity test.
He did.
What about the quality of the images? I mean, at the end of the day,
Yeah.
we want those images to look real.
Right. So for that, they used the FFHQ dataset, the one with all the human faces.
Okay.
They use a metric called FID. Lower scores are better.
Right.
R3GAN got a score of 2.75. Style Band 2 got 3.78.
So not only is it more diverse, it's generating higher quality images.
Than the model it was based on.
Wow, that's amazing. What about the other data sets? How'd it do on those?
So on CIFAR 10 and ImageNet, consistently achieved competitive performance,
Okay.
showed it wasn't just a one-trick pony, could handle a variety of image domains.
So better results, greater diversity, and it does it all with a simpler and more stable architecture. What's not to love?
And get this, fewer parameters.
Okay.
Smaller model, more efficient.
And it's faster than diffusion models.
Significantly faster.
So they've managed to make a GAN that's faster, leaner, more powerful.
Pretty much.
All right, this is a game changer. What does all this mean for the future of generative AI? Is this like the beginning of a GAN renaissance?
Well, it definitely throws a wrench in the idea that GANs are dead. It shows that, with careful design, a focus on those theoretical foundations, GANs can still be a major player in generative AI.
It's exciting to think about where this could go.
Yeah, absolutely.
Okay, before we jump into novel notions, where we get to speculate a bit,
I love this part.
let's take a step back and look at the history of GANs. See how we got to this point.
Oh, that's a great idea.
Like appreciating a masterpiece by understanding the artistic movements that came before it.
I like that.
So take us back to those early days of GANs. What were those first models like?
Oh, man. The original Jam paper, that was 2014.
That's a lifetime ago in AI.
It feels like it.
It really does.
Yeah, those early models, they were, like you said, like the first cave paintings.
Right.
Rudimentary, blurry.
But full of potential.
But full of potential. They could generate those simple images.
Yeah.
But training them, it was a nightmare.
Those stability issues, even worse back then.
Way worse.
So how did we go from those humble beginnings to something as sophisticated as R3GAN? What were some of the key breakthroughs along the way?
Well, there was a lot of research. Every new paper built on the last one, right?
Hmm.
New techniques to improve stability, image quality, diversity.
Yeah.
One of the big ones was convolutional neural networks, CNNs,
Okay.
for both the generator and the discriminator.
Right.
CNNs, they're really good at processing images, and they made a huge difference in the realism of the images that GANs could create.
Ah, so like switching from charcoal to oil paints. A
Exactly.
finer tool for a more refined output.
Exactly. And then you had those architectural innovations like StyleGAN.
Okay.
That was a big one.
Right, and its successors.
Yeah, StyleGAN, it brought this idea of controlling the image generation process by manipulating styles.
Interesting.
Allowed for way more control over the images.
So like an artist adding layers of detail.
Yeah, building up that complexity.
Okay, I'm starting to see how R3GAN fits into all this.
Right. It's taken those best ideas, simplified them, modernized the architecture.
Added that theoretical rigor,
Exactly.
like the new loss function.
It's really come a long way.
It really has.
Oh,
All right, you've teased it long enough.
okay.
Novel notions time. Let's hear what wild ideas this paper sparked for you.
Let's get speculative. All right, so this paper really got me thinking about relativistic pairing. That idea of comparing real and fake data during training. you know?
Yeah, like a constant back and forth.
Exactly, exactly. But what if instead of just comparing individual images, we went bigger? Like, what if we had a GAN that learns to generate entire data sets that are statistically similar to the real thing, but with totally new samples, never before seen stuff?
Whoa. Okay, so like a GAN that's a master forger,
Yeah.
creating whole collections of data. Why would we even need something like that?
Yeah. Okay, so think about scientific simulations. They're super useful, right? Studying complex stuff like how galaxies evolve, how diseases spread. But they're also really expensive and time-consuming to run. What if we could train a GAN on the output of those simulations and then use it to generate massive data sets that are statistically similar at a fraction of the cost?
Wow. Okay.
It could be revolutionary.
Yeah, it'd be like a shortcut to generating data that would normally take forever.
Exactly,
I
exactly.
mean, it'd be huge for scientists.
It would be like having a virtual lab assistant that can just pump out data on demand.
Yeah, exactly.
And it's not just science, right? Any field where you need realistic synthetic data. Think about market research, drug discovery, financial modeling, even like video game development.
Yeah, okay, you're blowing my mind here. That's a serious novel notion.
Okay.
But I have a feeling you have another one, right?
All right, let's go deeper down the rabbit hole. What if we combined R3GAN's stability and simplicity with reinforcement learning? Imagine a GAN that not only generates realistic data, but it also learns to achieve goals, like in a specific environment.
So like a GAN that's playing a video game, trying to like navigate a virtual world and complete tasks.
Exactly. Think about training robots, but doing it in a safe, simulated environment. We could use a GAN to create these crazy, realistic virtual worlds, and then let robots run wild in there, learn, experiment without any risk in the real world.
Right.
And then once they've mastered the task in the simulation, you transfer those skills to a real-world robot.
Wow, that's incredible.
It's like a virtual training ground.
I mean, and I can see this being used beyond robotics too.
Yeah.
Imagine like personalized virtual assistants, right?
Yeah.
That could interact with us in these super realistic ways. Like having a digital companion that really understands us.
Exactly. And the best part is with R3GAN, it might not be as far-fetched as it sounds.
Okay, you win. That's officially the wildest novel notion we've had on Talk Tensors. To our listeners, if any of you manage to pull off either of these feats, let us know. We'll dedicate a whole episode to your work.
Absolutely.
But for now, let's bring this deep dive into R3GAN to a close.
Yeah, it's been a fascinating journey, really digging into this paper.
It really has. You know, for me, the big takeaway is that innovation doesn't always mean creating something entirely new.
Yeah.
Sometimes the most groundbreaking stuff comes from taking another look at those old ideas with a fresh perspective.
With a solid theoretical foundation.
Exactly. And R3GAN, I mean, that's a perfect example of that.
It really is. And who knows, maybe this is just the start of a GAN renaissance, you know. In a few years, we might look back at this paper and see it as a turning point.
Yeah, bringing GANs back into the limelight.
It's exciting to see what happens next, both with GANs and with the whole field of generative AI.
I'm with you on that. As always, the link to the paper is in the show notes, so go check it out. Let us know what you think. Until next time, happy researching.
All right, welcome back to Talk Tensors.
We're ready to wrap up this deep dive into R3GAN.
Yeah, before we get to novel notions, let's take a quick trip down memory lane.
Okay.
GAN history.
I like it.
Give some context, you know.
Okay, so take us back to the beginning. What were those first GAN models like?
Man, those early days, the original GAN paper, 2014, it feels like forever ago.
Ancient history in the world of AI, right?
Right, it really is. Those first models, like we were saying earlier, they were rudimentary, blurry, but so much potential.
Yeah.
I mean, they could generate simple images, but training them, it was a real struggle.
Oh, I bet. Those stability issues, even worse back then, huh?
Oh, yeah, way worse.
So how do we get from those early kind of rough around the edges models to something as sophisticated as R3GAN?
Well, there was a ton of research, just a constant stream of new ideas. Each paper building on the last one, introducing new techniques to improve stability, image quality, diversity.
Right.
One of the big breakthroughs was convolutional neural networks, or CNNs, for both the generator and the discriminator.
Ah, CNNs, those are really good at processing images, right?
Exactly, and they made a huge difference in the realism of the images that GANs could create.
Right.
Like night and day.
And then you had Styligan and all of its successors.
Right, style again, that was a big one. Introduced this idea of controlling the image generation process by manipulating styles. Allowed for so much more control over the generated images.
So R3GAN, it's like the culmination of all of that research and innovation.
Right, it takes the best of the best, simplifies things, modernizes the architecture, and then you've got that theoretical rigor with the new loss function.
It's incredible how far we've come.
Yeah, absolutely.
All right, you ready to dive into novel notions? Let's hear what wild ideas this paper sparked for you.
Okay, so this paper, it got me thinking, what if we took this concept of relativistic pairing even further?
Right, directly comparing real and fake data during training.
Exactly. But instead of just comparing individual images, what if we compared entire distributions?
Okay, so like instead of looking at one image of a cat and one fake image of a cat, you're looking at like the whole concept of catness.
Exactly. Imagine a GAN that learns to generate not just realistic images, but entire realistic data sets. We could feed it, say, a data set of images of galaxies, and it would learn to generate a new data set of galaxies, statistically similar to the original, but with entirely new galaxies we've never seen before.
Whoa.
It'd be like having a GAN that's a master forger, creating these massive collections of data that are statistically indistinguishable from the real thing.
Okay, but what would be the practical applications of something like that?
Oh, so many. Think about scientific simulations, right? We use them all the time to study complex phenomena like how galaxies evolve, how diseases spread, all sorts of things. But those simulations, they're incredibly expensive and time-consuming.
Yeah, they can take forever to run.
Right, but what if we could train a GAN to generate synthetic data sets that are statistically similar to the output of those simulations, but at a fraction of the cost?
That would be huge. I mean, you could run so many more experiments.
Exactly. And it wouldn't just be limited to science either. Think about any field where generating realistic synthetic data is valuable. Market research, drug discovery, financial modeling, even video game development.
Yeah, I see what you mean.
The possibilities are really endless.
Okay, all right, that's a good one. But I know you have at least one more novel notion up your sleeve.
Oh, you know me too well. All right, for this one, let's take R3GAN simplicity and combine it with the power of reinforcement learning.
Oh, interesting. Okay.
Imagine a GAN that not only learns to generate realistic data, but also learns how to achieve goals, like within a given environment.
So like a Jan that can control a robot arm in a virtual world, something like that?
Exactly. We've already seen reinforcement learning do amazing things,
Hmm.
right? In game playing, robotics, all sorts of stuff. So what if we took those techniques and applied them to GANs?
Okay, I'm listening.
Imagine setting up a virtual environment, like a factory floor, and then training a GAN to control a robot arm in that environment. The GAN would get rewards for successfully completing tasks, like picking up objects and putting them in the right spot. And over time, it would learn to generate increasingly complex and efficient control sequences for the robot arm.
Wow, that is wild. So it's not just generating data anymore. It's actually learning to solve problems within a given environment.
Exactly. It's like teaching the GAN to think strategically.
Yeah, that is mind-blowing.
And think about the applications. You could train robots for all sorts of real-world tasks, but in safe, simulated environments. No risk of breaking anything, no one gets hurt. And once they've mastered a task in the virtual world, you can transfer those skills to a real robot.
Wow, that's incredible. All right, that's it. That is officially the wildest novel notion we've ever had on Talk Tensors.
I told you it was a good one.
And to our listeners, if any of you managed to make either of these ideas a reality, please let us know. We would love to have you on the show.
Absolutely. We would love to hear all about it.
But for now, let's wrap up this deep dive into R3GAN. It's been a really fascinating journey.
It has. This paper, it's a real game changer. It challenges our assumptions about what GANs are capable of.
Yeah.
And it really opens up all sorts of exciting possibilities for the future of generative AI.
It's a good reminder that sometimes the most groundbreaking innovations come from looking at old ideas with fresh eyes. And R3GAN, it's a perfect example of that.
It really is.
As always, the link to the paper is in the show notes. So check it out and let us know what you think.
Yeah, we'd love to hear your thoughts.
Until next time, happy researching.